So yesterday we talked about molar masses. You took the quiz. So far the grades have been really good on the quiz. So now we're going to use those molar masses as conversion factors, okay? Which is the whole reason why we kind of learn how to do that, because we're going to need them for conversion factors. What we're doing today is very important piece of the puzzle. Pretty much the first semester is learning the pieces of the puzzle, and then we're going to put the pieces of the puzzle together next semester when we do things like gas laws and stoichiometry. So we're learning this piece of the puzzle. This is, quite frankly, the most important piece of the puzzle is the grams to mole and moles to gram conversions. So that's what we're going to do. So now that we understand from yesterday Avogadro's number, which is the particles, which can be molecules, ions, or atoms, or formula units, we can use those as conversion factors. This is actually supposed to be 10 to the 23rd. It's just a typo instead of 1023. And remember, that's how many atoms are in a mole, or how many molecules, or how many formula units. All things that you need to recognize. Sometimes we'll just say particles, so that encompasses all three. And then, of course, we also have our molar mass, which we get from the periodic table for the element. And then if it's a compound, of course, we add them up like you did on your quiz today. Okay? So, before we begin, let's talk about something that we call the Brinkelhoffs. My screen seems to be stuck. It's saying waiting for screen. Come on. There we go. Okay? So we're going to talk about the diatomic molecules. Okay? Diatomic molecules simply means two atoms stuck together, okay? And there are certain elements that in nature, they do not appear all by themselves, okay? They're the Siamese twins of atoms, if you will, okay? And there's an easy way to remember that, and we call them the Brinkelhoffs, like a name, Brinkelhoff, okay? And what that means is that when they are by themselves in nature, they exist like that, Br2, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. So when they're all by themselves, they cannot exist by themselves as just one atom. They exist as a diatomic molecule. Okay. When we have the chart uncovered, you'll see that because I have my gases in red on that big chart, they're all the gases plus also chlorine, not chlorine, chlorine's already a gas. All the gases plus bromine and iodine, which are halogens, which is group 17, okay? So when they're by themselves, they have to be two of them. When they're in a compound, they can be anything. They can be, you know, for instance, in glucose, you have 6 oxygen, C6H12O6. Does not mean they have to be two. It's only when they are by themselves, okay? And we're going to use that all year, and if you don't write it correctly, I'll say, remember, that's a Brinkelhoff, and this is what I mean. It's diatomic. It means you got to have two of them, okay? All right, so let's just get into our gram to moles and moles to gram calculation. It's going to be a one step. Okay, we always remember start with what they gave us in the problem, which was 120 grams, right, of calcium. Before we start any kind of calculations, I'm going to look at that and I'm going to say my answer needs two significant figures because that's what they gave me in the problem. So if I have grams, I want to get rid of grams. So where do I put that unit in the next step? On the bottom. So grams of calcium, and it's always per 1 mole, right? So we look up the molar mass of calcium, and we get how much?
40.
40 what?
Grams.
No.
Per mole.
How many decimal places are we supposed to use? So give me again what the molar mass of it is. Are y'all looking at your periodic table? Y'all are looking at the head. It's 40.08. There was a mistake in the notes. So there. Get out those periodic tables. Okay. 40.08 grams of calcium per 1 mole of calcium. So now this cancels out. Okay. And then I have a number on the top, number on the bottom. So what do?
Divide.
I divide. Okay. If I divide that, I get 2.99 and some change. But I need two significant figures, so I would report that as 3.0 grams of calcium. I mean, not grams, excuse me. Back that truck up. Moles of calcium, because I canceled grams, okay? So always double check that you got the right unit, okay? So that's how you do a gram to mole conversion. So if I'm going grams 2 moles, I am going to divide by the molar mass. MM stands for molar mass. Okay? So if I have to go grams to moles and I divide by the molar mass, what do you think I'm going to do if I'm going to go moles to grams?
Multiply.
Makes sense, right? Multiply. So let's do an example of that. So this one is, you have 5 moles of sodium chloride. So immediately I'm going to say I'm going to need 3 significant figures in my answer because that has 3 significant figures in the given. So I'm going to say 5.00 moles of sodium chloride. I want to get rid of moles of sodium chloride, so I'm going to put it on the bottom. And I'm going to go to grams of sodium chloride. 1 mole, because it's always grams per 1 mole. I need to find the molar mass of sodium chloride. So I'm going to take sodium, which is 22.99, and I'm going to add chlorine, which is 35.45, and I should get 58.44 grams of sodium chloride per 1 mole. So now my moles cancel out. And I need 3 significant figures, and so that should, hopefully if you're doing it correctly, get 292 grams of sodium chloride. Did y'all get that? We did. Awesome. So if we're going moles to grams, we're going to multiply by the molar mass. Okay, now don't just do that and put it down. You have to show work, okay? Because later on, when we're adding our pieces of the puzzle together, we're going to add extra steps to this process. This is we're taking baby steps. This is the first baby step, okay? All right, so that's grams to moles, moles to grams. What if I want to know atoms or particles or molecules? What do you think I'm going to use? Oh, I'm not going to do this problem, but if you want to do it in your notes, this right here should be how many moles of PbO2. It's a typo because they're giving you that as your compound. So fix that in your notes if you want to do that as an example, and you can come see if you can come look at my notes and see if you set it up right. Okay. Now we have atoms, or it wants to know how many atoms of silver are in 4.25 moles of silver. Okay. So we're going to start with the 4.25 moles of silver. Next page. Because we're skipping some of those examples. Those are if you want to go do them, you can come check and see if you did them right. So I want to get rid of moles of silver, so that goes on the bottom. What conversion factor do we know that would relate atoms to moles? 6.022 times 10 to the 23rd, which is known affectionately as Avogadro's number. Did anybody in here get Avogadro, Amadeus Avogadro, Amadeus Avogadro as your dead chemist for your project? Oh, that's too bad. Cancel, cancel, because it's always per 1 mole. And so we would multiply 4.25 times 6.022 times 10 to the 23rd. And when we do that, we should get 2.28 or 29.
How many should we have?
3?
3. 2.66 or 2.56.
That's not what I got. Oh, I'm looking at the wrong thing.
I got 2.5.
Yeah, I'm looking ahead of my notes and I'm looking at the wrong thing. I'm sorry. I apologize for doubting you. 2 point what? 2.56 times 10 to the 24 atoms of silver. Okay? So when I want to go moles, I don't have enough room. If I want to go moles to, I'm going to say particles here because sometimes it's atoms, sometimes it's molecules. I'm going to multiply by Avogadro's number. I'm going to abbreviate that. A lot of people call Avogadro's number avocado's number. That's done every year. Okay? Okay, so now let's do one that we go from atoms to moles. So what do you think we're going to do with Avogadro's number there? We're going to divide by it. Just notice the pattern. We already did a mole, so let's do this one. We have 8.24 times 10 to the 24 atoms of sodium. So we want to get rid of atoms of sodium, so we're going to put that on the bottom, and always per 1 mole. So we're going to put Avogadro's number on the bottom, and I'm going to run out of room. Sorry. Okay, so now our atoms cancel out. Now, if you're using my calculator that we have in here, I very much encourage you for these type of problems to use that numerator over denominator key. Okay? Because the calculator does something weird when you try to just do it as a string, and it wants to add them, because a lot of kids were getting like times 10 to the 46 today. That doesn't make any sense. I'm dividing 24 by 23. I shouldn't get 46. Okay? So, excuse me, when you do this math, what do you guys get?
13.6.
Well, I need 3 sig figs, so how would I round that? 13.7 moles of sodium. Okay? So this time when I'm going atoms, or you can say particles, let's change that to particles. Because it could be molecules, it could be other things, and sometimes when we just write atoms we get confused. So if I'm going particles to moles, I divide by Avogadro's number. Okay? So that's how you do those. Now we're going to put it all together and we're going to do a two-stepper. Okay? So who's ready to do the two-step with me?
I'm ready now.
Okay. All right. So two-step conversions. You cannot go directly from grams to particles or particles to grams. We have to go through the middleman, or the middle mole, if you will. So we're going to have to go through moles to get there. Okay? So we're going to start this problem, and we've got 3.99 grams of potassium. So we're going to need 3 significant figures. Hopefully you're getting in that habit of looking at it and deciding at the very beginning. It's much easier to do it then, so that you go through the problem thinking, okay, I'm going to need 3 significant figures, instead of at the end writing down all those decimals, and then I don't like that, and I don't count it right sometimes, or at least count some off. So 3.99 grams of potassium. Okay? I need the molar mass. That's the only way I can get out of grams, is using molar mass. 39.10 grams of potassium, 1 mole of potassium. So I got rid of my grams. Now that I'm in moles, I can go moles to atoms, since we're dealing with an element. So 1 mole of potassium is equal to 6.022 times 10 to the 23rd atoms. Okay? So my units cancel out. So I do that math, and what do I get?
Times 10 to 22.
Okay? So now let's do one where we're going to go from atoms to grams now. So I can see one of each kind. Ready? Anybody still writing? Okay. One person still writing. We'll wait a second. Any questions so far? It always looks easier when I'm doing it. When you're doing your homework today, go back and follow the examples. Look and see what kind we did, because I gave you an example of each type that's going to show up. Okay? All right, so let's do the other type. Let's go from atoms to, that's ironic, it's helium. Oh, sorry. Oops. Okay, so we have 3.03 times 10 to the 21 atoms of helium, which is spelled with only one L.
Yeah, I got it now.
All right, we want to get rid of atoms, so we have to use Avogadro's number. To the 23rd atoms of helium to 1 mole of helium. Okay, got rid of atoms. So now we can use the molar mass to get to grams. So we have 1 mole of helium. If we look up the molar mass of helium, it's 4. Technically it's 4.00, but we can just write 4 here. All right, again, when I have the 2 exponents on the top and the bottom, I encourage you to use that numerator or denominator key. And it should be, I'm going to ask myself before we do this, it should be, I should expect a very small number, or at least a decimal, because I'm taking a 21 and dividing it by 23. So it's kind of a way for me to just kind of gauge, did I plug it in correctly? I'm going to need 3 significant figures from the problem. And hopefully if you did this correctly, you got 0.0201 grams of helium. And is that what y'all got? Perfect. Okay, did you get like times 10 to the 46 or 45 or something like that? It's the way you're plugging it into the calculator. Let me finish this lesson and then I'll look at the way you're plugging it in, okay? Okay. I guarantee if you use that numerator over denominator key, you'll get the right answer. That makes a difference in the way, for some reason the calculators that we have in class, if I plug them in that way on my TI-84, it works great. But if I plug them in the same way on that calculator, it does something weird with it. So,
If you use parentheses.
if you use parentheses or the numerator over denominator key, it works.
How do you use
Okay.
the numerator? How do you get to it?
Can I check? Let me finish the lesson and I'll show you. It's super easy. Okay. All right. So we have this little bit of a flow chart right here that you can use, and notice it has the double arrow. So if you're doing a 2-step conversion, you can use that. If I'm going grams, I go this way and I go to moles and then I go to atoms using those conversion factors. Okay. All right.